Wow, popular talk. Right, okay. A lot of familiar faces, but for those who don't know me, my name's Julian Browne. I work on the Online at the Core programme, but I work solely on the e-commerce part of the Online at the Core programme, so I'm kind of like a lodger that won't go away as far as the online domain goes. Right, so this is a presentation about the web. It's a presentation about the web that we know today, and it's also a presentation about the web that might come, or the web that we could have had that might come. It's also a presentation about architecture. Architecture is a bit of an interesting topic because it's actually quite hard to define what architecture is. We know it's not directly to do with, well, it is related to development. We know it's actually not the same thing as development. We know that a good architecture can make a big difference to companies like Amazon seem to have a fairly good architecture. And we know to our own cost that a bad architecture can pretty much kill a project off. So, with that said, the idea for this presentation goes back probably about 6 or 7 years when I came across this website. Jeff Bezos, who's the CEO of Amazon, was talking about a project that's run by this foundation called the Long Now Foundation, and he's a major investor in the Long Now Foundation, and they're trying to build a clock that will last 10,000 years. It was conceived by a guy called Danny Hillis in 1995, I think, and he's a guy that started a company called Thinking Machines and sold it to Oracle, made a load of money there, then started a company called MetaWeb and sold it to Google, made a load more money. And the guys that sit on the foundation of the Long Now are all basically guys that have made an awful lot of money and got a bit too much time on their hands and are obviously thinking about what their legacy to the world is. So they've come up with this idea. One of the projects, there's many that they do actually, is this 10,000-year clock. And what fascinated me about the 10-year clock is a lot of the problems that they're going to need to solve are very architecture-like problems. How do you design a clock that's going to last 10,000 years? Where would you put it? What would you make it of? How would it power itself? How would you maintain it? All things that are about thinking very far into the future. And I started to think, how would you apply that kind of thinking to architecture? An interesting statistic is if you buy a piece of software these days and install it in a corporate environment, its lifespan on average is about 5 years. If you build a system, its lifespan on average is about 10 years, which seems to me to be quite depressing. You think a sizable program now, Online at the Core kind of size, you don't get any change out of about £50 million. If that lasts 10 years, that's the equivalent of about £100,000 a week that you're spending over the 10 years, which is a pretty depressing statistic. So why does it need to be like that? Why can't we think about things in a different way much longer than the kind of 10-year lifespan? So I'm not proposing what my answer is to the 10,000-year clock. They have actually started to build it. If you go to that website, there's a whole load of stuff. Bits of it are actually already working. So has my mic just gone off?
Yeah.
Hello? I don't think I muted it, did I?
Just talk loudly, Julian.
Am I being picked up for the camera? Because that's the main thing. Okay, right, I'll just shout. No. I meant for posterity, not for... Hello? This one? No. No, they've all gone. Don't worry, I'll just talk really loudly. I'm used to that. Okay, so let's talk about architecture for a second. If I were to do a presentation just on architecture, I'd talk about these kind of concepts. These are the sort of things that architects talk about a lot. There are a number of different techniques about how you actually build a good architecture. And I could have easily done that and still talked about what 100-year architecture might look like. And then I thought, you know, it's Christmas and everybody's kind of off-site, and if I start talking about techniques for domain decomposition, people in the audience would be like, oh, is that the time I've got a conference call? I'm just going to, nip out. So I thought, well, it's not going to be that exciting at this time of the year, and, you don't really want to get into some kind of boring architecture, especially not from an architect. So I thought I'll take a different perspective on this. So thinking about the whole kind of, how would you build an architecture that was, okay, maybe not 10,000 years, but let's say 100 years. What's an example of a really good architecture? And the best architecture that I could possibly think of is the web itself. Why is the web a really good architecture? Well, there's kind of two perspectives on that. One is we're all consumers of the web, and it's had an amazing growth cycle since it came out. In fact, it sort of exists a good 5 or 6 years before this timeline begins. As a consumer of the web, right now, I could open up my iPad, I could read some reviews of a holiday resort, I could book a hotel there, I could book a flight there, I could book a hire car while I'm there, I could order a pizza to eat while I'm doing all of these things, I can buy some clothes to wear, a book to read, and I can go there, I can take some photos of me in my Speedos, and when I come back from holiday, I can put them and share those photographs, obviously in a very select group, if it was me in my Speedos, and I can do all of that with nothing more than a browser. I don't need to go on a training course, I don't pay any vendors any money, I don't even need to talk to another human being. And that's a really powerful thing from a consumer point of view. And then if you think of it kind of from the inside out, architecturally, the web has got to be the most amazing application development platform that there's ever been. I can do all of those things. I can also quite confidently say that in a year's time, I'll be able to do a load of things that I can't even imagine now. And when I was thinking about that slide, I was thinking about priority moments. I noticed some of the guys are here. A year ago, priority moments was barely more than an idea in online, and now we've got this amazing platform which has had astonishing growth rates and is actually more popular, if you look at the statistics, than Foursquare for its own user base. And that's in part because it's based on web-type architecture. So without having to think about some of the technical practices and so on that architects get sometimes a bit caught up in, the web is something that we're all very familiar with, and it proves that there is something there that works. And the underlying architecture of the web has barely changed since the day it was very first conceived. And it was conceived by this guy, who some people here probably know is Tim Berners-Lee. I was going to make a joke that Tim Berners-Lee looks slightly creepy and sinister in that picture, but last night I had the slides open and my son said, "Is that you at work, Daddy?" So I'm going to say that he's an extremely handsome chap that we should all look to for inspiration. And so Tim Berners-Lee started the web before it was actually called the World Wide Web. It was called Inquire. That was the name of his project, and he built this software which was called Inquire, and it was based on a book that his parents had around the house, which was actually first published in 1856 and has been an incredibly popular book. It's not in print anymore, but you can actually view all the pages of it on the web. And the idea of the Inquire Within Upon Everything book was that it was like an almanac that you could ask any question of, mostly around domestic things like how to get a soup stain out of a tie or something. But it professed to be able to answer any question that you had. So inspired by that book, because he'd obviously seen it as a child, he called his project Inquire. And he was working on Inquire at CERN, so that's where the Light Hadron Collider is right now, so where all the physicists in Switzerland all get together and do amazingly clever things. So they were kind of that's where the requirements for Inquire came from. But what's happened in most technical subjects over the last 100 years or so is they've become more and more specialist, which means it's much harder for people to share information. It has to be specialist in order to push the boundaries of science forward. But the more specialist you become, the less you know about other people's subjects. So there was a desperate need for people to be able to share information in clever and informative ways. And this is these pictures on the left-hand side. They're actually screenshots taken of diagrams of Tim Berners-Lee's presentation to his bosses when he said, "I'd like to do this thing called Inquire." What's fascinating to me is at the top, and it's all the way through his document, he keeps talking about a browser, because nobody knew what a browser was then. You can imagine his boss going, "Yeah, so this browser thing, Tim, that sounds good, like it'll never fly." And then the other thing is, this is a quote taken from his paper, which was published internally in May 1990, is that the whole point of this was it was an academic thing. The idea of streaming media and stuff like that was never even conceived of, and yet he managed to build this thing that now does that kind of stuff as almost like second nature. And this is a screenshot of his actual desktop. You can't see it easily, but it actually says Tim's homepage at the top. And you can kind of make out that it does look, I mean, it's very basic, but there are actually web pages there with links in. And he worked with a guy called Robert Kaylor, who was like his kind of development buddy when they were working on Inquire. And the paper was published in May 1990, and on Christmas Day 1990, they actually got the first web server. They both had a browser installed, and they were both able to actually browse some stuff. And what I found quite fascinating was that was actually on Christmas Day. So his wife was like, "Tim, come and open your presents." And he's like, "I'm just on the web. I'll be down there." And it was probably the first and last time that you can say that he definitely wasn't looking at porn, because there wasn't any then. He was looking at physics papers, which is probably just as bad. So fast forward a year from that date. So the Inquire's been working for a year. It's now changed its name to the World Wide Web. And in December the following year, there was the Hypertext Conference, where all the people, all the scientists around the world interested in hypertext got together to talk about, the future of conference, very much like this, I imagine. And Tim Berners-Lee wasn't even able to get a speaking slot at that conference. They gave him a cork board in a corridor and told him he could put up some pictures of his World Wide Web. Where's it running, Tim? Well, in my office with Robert. And that was it. So, and what struck me when I first saw that picture is I thought, how could that possibly be? The guy that invented the web wasn't even allowed to talk, wasn't even able to get a speaker slot at the Hypertext Conference. He'd be like the keynote speaker at a Hypertext, surely. And the reason for that is that Tim Berners-Lee didn't invent hypertext or hypermedia or any of those other things. He built something, which we call the World Wide Web, but based on what a lot of other people were thinking at the time. And the concept of a link was not Tim Berners-Lee's idea. The concept of a link actually goes much further back than 1990. It actually goes back to the Second World War. And the guy that was responsible for all the scientists that built the atomic bomb and a number of other things that the American military put together was this guy, a guy called Vannevar Bush. And Vannevar Bush was like one of the first ever kind of real IT guys. In the 1930s, he worked on calculating machines. He worked on pre-digital electromechanical computing. And he ran a team of about 3,000 scientists for the American Defense Department, one of which was the team that worked on the bomb. And at the end of the Second World War, you can imagine all these scientists, they all sort of got together, and I imagine they were probably proud of the scientific work that they'd done, but they'd also made this fearsomely awesome weapon, and they were thinking about how to try and find some good in the work that they'd done. And Vannevar Bush published an article. I couldn't actually find a screenshot of the actual one, but the Atlantic magazine, which is still going today, in June 1945, he published an article in the Atlantic magazine called As We May Think. And it was republished in Christmas again in Life magazine, which is, some people refer to the Life magazine version of that article. And he said a couple of important things, that from his experience of working with all these really clever scientists, that he'd noticed that human beings tend to, and this is kind of obvious now, but at the time it was fairly revolutionary, tend to actually think of topics or subjects, and in their mind they jump to another topic or subject, and another, and another, and another. And he actually said, it's a very long article, this is probably the most important paragraph of it, that if you could somehow harness that way that human beings think, there's a great possibility for some interesting stuff to come in the future. That little picture there, he's reckoned, it's not very well known outside of the States, but there is a Vannevar Bush medal that's given to scientists in the States every year. And the second thing that he said is that if we could harness technology, and I remember he was an electromechanical guy, digital computing was really just about coming in to popularity around the end of the Second World War. In the UK, Alan Turing and Tommy Flowers were working on the first digital computers, so we were kind of neck and neck at that time. But what he said is if we could do the thing at the top with computers, then we could actually generate a whole new form of encyclopedia that would have those web of trails, as he called them, that would allow you to follow them, and that would actually, it was called As We May Think, because he actually thought that this technology. Right, starting again. Where was I? Yes. Okay. So Vannevar Bush. So that's too loud now, isn't it? Can you turn me down a bit? Is that all right? Okay. So yeah. So Vannevar Bush said, "This is the way we think. Harness the new digital technology." So as I was saying, he was an electromechanical guy, feeling a bit left out at the time about the whole digital revolution. In fact, after he wrote that paper, he spent the next 30 years rewriting it for digital technology. But the insight was kind of there and published, and the rest of the world started to pick it up. So where are we with 100-year architecture? This is kind of a summary of where my web of trails was at the time that I read that paper. Is you've got Vannevar Bush, influences Berners-Lee, builds the web, and then we can start to kind of make some insightful pronouncements about what we have and where it might go in the future. Except you can't talk about the web without talking about this guy. So where Vannevar Bush talked about webs of trails, the guy that actually took that idea and turned it into what we know today as a hyperlink and hypertext was this guy called Ted Nelson. And Ted Nelson started thinking about this stuff in 1960 when he first went to college, coined the phrase hypertext as early as 1963. So you can see this stuff, the way that the web works, the basic principles it's founded on is way, way older than anything that Tim Berners-Lee ever did. He may not have even been born then, actually. He coined hyperlink, hypermedia. I was sat in the presentation that Andrew did just now about the mobile phone payment stuff. Ted Nelson also started to think about how web technology or hyper technology would actually apply to things like payments. And I think it's fair to say that some of Ted Nelson's ideas around that are nowhere near even realised yet technically. The other thing that Ted Nelson's quite famous for, it's not part of this presentation, but he also coined the phrase teledildonics. Which, okay, so some people do know what it is. If you want to look it up, it's a different kind of interactive experience that you might get on the web. And in 1974, Ted Nelson published this book, which became an immediate success, became a bit of a hacker manifesto, even though Ted Nelson wasn't a programmer himself. He was more of a kind of a linguist and a visionary, although it's a word he doesn't like used about himself. It's a two-part book, Dream Machines and Computer Lib. It was self-published. It's very, very hard to get copies of it now. I'm desperately searching for an original edition on eBay, but they tend to go for about 800, 900, 100 quid. And he, although it's not directly related to this presentation, in 1974 he recognised that, sorry, in 1987 in the updated version, he said that computers were basically oppressing you in your living room. If he updated it now, I mean, you can basically be oppressed by computers wherever you go. You can't get away from them. So our overview of where we are with 100-year architecture now is this. 1945, Vannevar Bush has this amazing insight about the way that human beings think. Ted Nelson formalizes it into hypertext and hypermedia. Tim Berners-Lee is influenced by that and makes the web. This is kind of where we are now. And then we can talk about our 100-year architecture and look at some of the features that we've got. But all of those guys have really driven what I would call the web from the outside, so how the human interacts with it. This guy has done probably more than anyone else to kind of recommend to the world that actually underneath all of this stuff, as well as it's not about consumer experience as much as it is about the architecture that drives that experience. So as I said at the beginning, the web has hardly changed, and the internet underneath the web has hardly changed for much, much longer than that. Some of the early internet sort of inventions, SMTP, they go right back to the early 70s. And Roy Fielding is most famous, I guess he's most famous in online for REST. So in 2000, Roy Fielding published a dissertation which is the definition, it is the only definition formally of what REST actually is. This presentation isn't about REST, but he's the guy that did that. And he's also co-responsible for this. Most people won't know what RFC 2616 is, but you will know what it means to us, which is it's the HTTP bit that sits at the first part of your browser when you type in a web page. Roy Fielding worked with a number of people to do it. I think there's about six authors of the HTTP protocol as it formally exists today, but Roy Fielding and Tim Berners-Lee obviously were the two main guys that did that. And HTTP is it's the lifeblood of the web. I mean, the HTML stuff on the top is almost incidental. the thing that makes the architecture of the web what it is HTTP. So HTTP was invented as a sort of standard protocol by Tim Berners-Lee in 1990, formalized in 1996 via the IETF as version 1. Then for a short time it existed as RFC 2068, then became what it is now in 1999. So this is already kind of 12 years old. And then the other thing that Roy Fielding was responsible for is the Apache web server itself. So he kind of looked at both the sort of currency, the network currency of what the web is, plus the servers that would actually talk it. And what's amazing about HTTP, and I think this is the reason that architecturally it's so great, is it's not really an empowering technology, it's a constraining technology. Almost all the best architectures of any kind are architectures that tend to constrain you as to what you can and can't do. So HTTP, I've used sort of slightly high-level language in keeping with my It's Christmas theme. HTTP will let you fetch something. So when you click on a link, your browser goes away and does an HTTP GET and pulls back some resources. It will also let your browser check something. So it can go to the web server and say, can you give me some metadata about that resource? Like, has it changed since the last time I looked at it? It can also update something. So when you click a button on a form, you're not actually doing a GET, you're doing a POST, and that's updating a resource at the far end. You can override a resource, overwrite rather, a resource rather than just make changes to certain aspects of it. And you can delete resources. You can redirect, you can tell the browser to redirect somewhere when something's moved, either permanently or temporarily. Fascinating stat about that is HTTP Archive, I think it's called, which has loads of stats about HTTP since the web really started, says that right these days 66% I think it is of links actually redirect on the web. So most links that you go to are not actually pointing at the thing that you thought they were pointing at. They're telling you, the browser, to go somewhere else. And the browser can also query the web server to say, well, what of any of these things am I allowed to do against that resource? So great basis on which to build an architecture, because you can replace something with a customer or a product. And it's not just it doesn't need to be limited to a web page. And that was kind of Roy Fielding's insight. There's been some interesting sort of infighting in the web community about whether he sort of nicked that idea from HTTP or whether he came up with it himself. But either way, he's the guy that published the dissertation and sort of owns the REST standard. And that takes us back to Tim Berners-Lee. So we end up with a web, some standard protocols, they're all signed off, everybody uses it. We have this, oh God, I'm not having a lot with this, am I? We're coming through the moon in a minute. And yeah, so Tim Berners-Lee and the web. Now, this is a kind of our summary of where we are right now. Bush influences Nelson, separately influenced Fielding for REST, separately influences Berners-Lee, but they work together and build the web. Which means my entire presentation really ought to be focusing on the inflection point in this journey, which is Ted Nelson. And I could tell you why the web is an amazing thing and all the ideas that Ted Nelson came up with that we've built into the web. And this is where it goes wrong, because Ted Nelson actually thinks the web is a pile of poo. And he's been very outspoken about this. And to be fair, well, I did a little search, his negativity about the web, this is 2001 from the BBC site, he's actually been negative since about 1996 in public. I imagine it goes back before then. So I'm going to take a slight detour away from the web now, because there is... Let's all sit in a campfire circle. No, I'm sorry, don't. Well, I feel a bit weird doing this, but I'll move up a bit. Yeah. Okay. So there's some precedent. I thought I should go right the other end. There's some precedent for this kind of thing in IT. So academics coming up with great ideas that don't get taken up initially, but then have some influence on technology at a later stage, is actually quite a common pattern. And you see this over and over again if you do any research into what people said and then what eventually gets built. And the very strong comparison with what Ted Nelson said and programming is this guy. this is John McCarthy, who also spent a lot of his time saying, you're doing it completely wrong. Fortunately, he died a few months ago. Not because of that, but he's a very interesting guy, and he wrote some fascinating papers. He was an artificial intelligence, one of the pioneers of AI actually at MIT in the States, and he invented this language. And like Ted Nelson, John McCarthy conceived of Lisp really before there were the same number of programming languages that there are now, and really before we'd started to get into our mindset what OO is and all those other things. So he was kind of free to invent a language which was all about how do we explain to a computer what we would like it to do. And Lisp is a functional programming based language, which is quite different than a lot of languages that we've known and built software with over the last 20 odd years. But it's gathered quite a following. You can always tell people that actually code in Lisp because they're very, very smug. Guys like Eric Raymond, who wrote The Cathedral and the Bazaar, which is an amazing book on open source technology. It will completely change how you view open source. Also wrote a piece called How to Be a Hacker. And I've read a couple of things about Lisp. I've done a little bit of Lisp programming. I'm not really, because I'm not smug, so I've not done a lot of stuff in Lisp. But it is true what they say. If you read McCarthy's work, and you read especially the slightly more humanized versions of it, it is a profoundly enlightening experience. It does actually tell you an awful lot about what software development is, which totally gets lost when you think about what Java was when it first came out. And the life cycle of Lisp has gone a bit like this. John McCarthy created it in, I think it was about 1958. And the only real contemporary language around at the time, Fortran was quite popular, but was BCPL. BCPL became C, which I guess a lot of people, that was the language I first developed in. And then C gave way to C++. So although they're not technically related, is it a new battery? Yeah. I'm suddenly going to get really loud, aren't I? Although they're not technically related, each one heavily influenced the next one. C++, as most people here will know, gave way to Java. So Java's attempt was to really clean up a lot of the OO mess that C++ left behind. No? Yes. Yay. Oh, thank God for that. I've got a terrible throat. So, and Java runs on the JVM. So this is kind of where we've been in software development for an awful long time. Lisp sitting out there with all these smug guys going, yeah, you should really just get to know functional programming because it's awesome. And then the Java guys sort of being much more delivery focused and building stuff on the JVM. But Lisp has actually ended up having possibly not the impact that John McCarthy wanted, but it has heavily influenced the way that languages are going now. So Phil, I know, talked about Groovy earlier on. So Groovy is like a dialect of Java. It runs on the JVM, so you've got some nice backward compatibility, but it's heavily influenced by what Lisp was proposing. And then you've got Scala, which it's not really a direct descendant of Java, but it's got an awful lot of Lisp-like features in it, but again, it runs on the JVM. And then you've got Clojure. Now, Clojure is much more like a Lisp direct descendant, but again, also runs on the JVM. The point of this slight detour is that if I were putting money on where programming is going over the next 10 years, those three things at the bottom, that's where I would be thinking where my money's going to go. So John McCarthy may have sat on the sidelines for a long time and saying, you know, Lisp is awesome, and everybody was like, no, we'd rather stick with Java. But he's kind of had his way because eventually his argument won through, and now we've got these much more powerful languages. I mean, the lines of code that you need to perform the same function in these languages is a lot less than Java, a lot less if you compare it with something like C. And so if you kind of map that onto what I was originally saying, Nelson is a bit like John McCarthy in that he's out there going, the web's a pile of poo and it shouldn't be the way that it is. But we've got the web in the same way that we've got the JVM. So we've got no choice. We can't, I mean, although you can evolve software more easily than you can evolve hardware, we're kind of stuck with these two things. So the question really is, what is it that Ted Nelson thinks is rubbish about the web? Is he right in saying that it's not great? And even if he is right, is it likely to influence the future? So my proposal, and you can kind of make up your own mind. We'll talk about exactly why Ted Nelson thinks the web sucks in a minute, but my proposal is actually I think he is right. He has got a very fundamentally powerful point, which I think will actually come to influence the web over the next, and it may take a long time to roll out, maybe not 100 years, but in the next 10, 20 years, I think we're going to see a lot of what Ted Nelson was talking about become real. The reason, and this is a guy, Paul Graham, who wrote a book called Hackers and Painters, which if you work in software development, you really have to read, because it's, again, it's another one of those profoundly enlightening, very, very readable books as well. But Paul Graham said this. He said, most big corporate organisations, average corporate organisations, in an average year, in an average market, will grow about 10%. And what that means is, if you have a strategy that you basically do what everybody else does, buy your products from Oracle, you build them the way that everybody else does, the best you can hope for really is to grow around about 10% in an average year. We're not experiencing average growth right now, obviously, but if you do what everybody else does and that's the average, then that's pretty much what you're going to get. And that might be fine, but the big risk, especially to companies like O2, is you have these things called startups. And startups can't do what other startups do on average, because an average startup goes out of business. They don't grow at 10%. They literally just go out of business. So if you're a startup, you simply can't afford to mimic what all the other startups do. What you have to do is you have to find something different. And on the commercial side, that will be your unique selling point. But on the technical side, it will be your intellectual property. And that may extend all the way down to the language that you use to develop things in, or the architecture that you build on. So you're always trying to find something different, but not different, randomly different, because randomly different will probably still make you go out of business. You need some kind of logic to why you're different, and you need to have some sort of intellectual property. Okay, I've got about 7 minutes. This is going to be a really quick presentation. So this is why I think that you can say that certain academics, when they stand on the sidelines and say, as long as it's properly thought through, it is a candidate for startups to find and then say, you know what, we're going to build our architecture based on what that guy said because it makes sense and it will make us different. So you're looking for something odd in the market, but not completely crazy. So let's go back to Ted Nelson briefly and look at why he thinks that the web is fundamentally flawed. So Ted Nelson, throughout his career, has been kind of channeling Vannevar Bush, who said, and remember, he didn't say as we think, he said as we may think. So he was actually suggesting that we might think in a different way. And he was also channeling another guy, and most people who write about Ted Nelson don't realise Ted Nelson himself, in fact, as part of the research for this presentation, I emailed Ted Nelson and asked him some questions and did actually get a response. So I know that this is true. He was influenced by a guy called Benjamin Lee Whorf, who was a linguist in the like 1930s, I think. And what Benjamin Lee Whorf said is that the way that human beings express themselves, language, words, influence the way that we think, not the other way around. And all 20th century literature is really based on that concept. And it kind of makes sense, because advertising wouldn't work if that wasn't the case. You couldn't actually say something to someone and influence the way that they thought. That's a very fundamental concept to get into your head. The way that you think does not affect how you express it. It's the way you express stuff affects the way that you think. So this is what Ted Nelson these are kind of his two major influences. And Ted Nelson's big beef is with paper. So paper is about 1,000 years old, invented by the Chinese. What Ted Nelson said is paper is a prison. If you want to write something even mildly complex, any kind of, even trying to describe this presentation, you'd start to write some paragraphs down, and by the time you get to the second or third paragraph, you'd feel like you wanted to write a footnote, because it wouldn't quite fit in the flow of your thoughts, but you'd want to make a comment on one side. As you started to fill up some pages, you'd end up with a glossary, then you'd end up with an index. But then to explain some more esoteric concepts, you'd end up with a companion document, then you might have a website. And what Ted Nelson said is, ideas, human ideas, as you try and explain them, want to be free. They don't want to sit on a page, and a page is a very restrictive thing. So it's been enormously empowering for mankind to have paper, but actually it doesn't really fit with the way that we think, as far as the way we express it. And more importantly, although it's not a bad medium, it's the way that we store it and retrieve it and index it and so on that is really where it all falls apart. And it does so because of these things. What Ted Nelson called intertwingularities. Intertwingularities are more easily shown than explained. when Tim Berners-Lee did his presentation to his bosses, this is a picture taken from his paper. It's in effect a mind map. So what Tim Berners-Lee said is, here's something I'm describing, which is my World Wide Web project. It's based on hypertext, hypermedia, it links information. I'm calling it Inquirer. This is slightly before it got its later name. Runs at CERN. Here's the structure of CERN. So it is, to all intents and purposes, exactly what a mind map is. Human beings tend to find it much easier to communicate complex information, if you want to do it succinctly, using this kind of approach. If you've ever had an email from Brendan O'Rourke, he's not here at the moment, is he? But he tends to communicate in one of two ways. Either one-line emails, I get a lot that say, who are you, why are you bothering me? Or mind maps. The number of times it's like, could you go and work on this thing? Yeah, can you tell me what it is? And then he sends something that looks a bit like that. And that's actually quite a common thing. I've known a lot of people that if they want to get a lot of information out really quickly, rather than send you 4 sides of A4, which you won't read, they'll send something like this. Here's another one. This is the guy that went onto Wikipedia at lunchtime on a Sunday and opened up the page on the First World War and kept following links and writing down what he found until he found that the First World War links to Dusty Springfield. And then he stopped. And they say the web isn't useful. So the intertwinglarities are basically the lines that link these kind of concepts. So things are not easily defined. Everything links to everything else, and the links are what's really important. And the guy that's doing the keynote, Ian Robinson, who's talking about their product, which is Neo4j. Neo4j is a formal database technology based on formal mathematics that is all about links, which is another one of my reasons for thinking that some of the stuff that Ted Nelson says is going to come true, because I think the beginning of it already is. And here's mine. This is my intertwingularity map of this presentation. So I started with the idea of a clock architecture, weaved around various different things. You can see some stuff that's going to come up soon, through Ted Nelson, and so on. So Ted Nelson, in his Dream Machines computer lib thing in 1974, basically said that everything in the world is intertwingled. You might think that there are subjects, but in actual fact there are no such things. They're just arbitrary classifications that humans come up with. And he also said, going back to how we sort of file stuff, is that we've come up with this idea of hierarchical filing of concepts because that makes it convenient for us. In actual fact, it makes it convenient for computers to do it. And actually that's fundamentally wrong, because you're just reinforcing the fact that there are these topics that exist in isolation, and in actual fact they don't. And he said if you want to fix this, you've got to go right back to the basic element that you describe concepts in, which is the file system. And that itself, so talking about how language influences the way that you think, this is the icon that we tend to use for a file system. But it's not a file system. A file system is a manila folder with a load of paper in it that you stick in a kind of filing cabinet. It's got bugger all to do with a hard disk and the thing the stuff that you store on it. We've used that terminology. And so really what Ted Nelson said, and this is his big problem with the web, is in the 1950s and 60s, there was an amazing opportunity to actually take a step back and say, how do we want this technology to work? Because we can make it do. Computers don't presuppose the way that you want to structure and communicate your information. It can be anything we want. And what we did is we took paper and file systems, because we found it easier to make that kind of semantic map. And he basically said that was a lost opportunity. So I'm going to do this stuff really quickly because we're running out of time. But red team on the left-hand side, editor creates a web page. This is Tim Berners-Lee version of the web. Puts in a hyperlink that links to the blue team page created by the blue editor. When the red guy goes on the red page, sees the link, he knows that there's a link to this other page, but doesn't really know what it is. He might get some context as to what the words are that's making up the hyperlink. And he can follow it, but there's no semantic meaning to that link itself. It's just a link. It doesn't tell you anything about what that link is. The blue team don't even know they're being linked to. I mean, they could if they looked at their web thing, because you get the HTTP referrer header, but there's nothing in the page that says they're being linked. So anybody starting on the blue side cannot find the red side, and if that's a very important link, you've lost something. You've lost the ability to actually join those things together. So that kind of intertwingularity between those two concepts is great from the left-hand side, rubbish from the right-hand side. And if the blue team delete that page, you'll get a 404 because that page is gone. But the red team won't know that unless they actually, again, put something in or go and check that link and remove it. So it's kind of sucky. And so I said all that stuff about, you know, you could buy it, you book your holiday and whatnot online. So the web is great, but how many times have you actually been searching for something? And if it's 5 or 6 years old, the bloody link points to nothing. It's really frustrating. So what would Ted Nelson's Twingly world, my phrase, actually look like? Well, he called it Xanadu, not because he wanted it to be associated with the Olivia Newton-John movie, but because he had read the Samuel Taylor Coleridge poem, and obviously something about that spoke to him about Kubla Khan's palace or whatever. But we don't surf the Xanadu, we surf the web, so clearly his ideas about Xanadu, which he desperately did try and build, never came to anything. So Xanadu has, now not surprisingly, he's trying to invent a new kind of paper which exists in a digital world. So he's come up with some terms of his own. I can't get these. There's a file system, but he has a slightly different way of viewing a file system. He has transclusions instead of links, so they're a bit like links that we know, but instead of, if you wanted to quote another page, you'd actually not have a link to that page. It actually takes the content from that page and embeds it into the page that you're looking at. So it's a sort of transfer inclusion, which is where the word comes from. Links have a type, so you can actually, by looking at a link, you can actually see the meaning of it, so you'll know whether you want to follow it. So if I wrote an academic paper, I could link to academic papers that supported my theory or rejected my theory, and the link would tell you whether it was worth following because of that. Links work both ways. And when I'm viewing one document, I should be able to see the document that's actually the closest companion document that's describing what I'm actually viewing. And every time I change the version of anything, everything gets kept up to date, but I can still see previous versions. He also came up with a load of other stuff, and this is just a tiny subset. He's coined about 80 phrases. The guy's gone nuts. I won't bother explaining those because we just simply don't have time, but if you want to, I'll put some links in the slides if you want to go and follow these, if you want to find out what an enfilade is. So anyway, so this is the kind of the little timeline of Ted Nelson. Started thinking about it in 1960, 1971 to 1978, he finally worked with some other people to try and build it. 1979, hired a house in Swarthmore in the States, and they said, right, this summer we're going to build Xanadu, and it's going to be awesome. And then they ran out of time. Actually, they hired computers, and the computers had to go back to the shop. So, a total waste of time. Then, following 7 years, worked with some other really clever guys. There was one guy called Roger Gregory, who he met in about 1970, who was kind of the stalwart of Xanadu, still trying to build it now. And he had his best chance in 1988 when John Walker, who was a multimillionaire who invented Autodesk, said to him, you know what, I'm going to sort you out. I'm going to give you a building, and I'm going to design the whole inside of the building. I'll get you the best developers that there is. Now remember, 1988 is, what, 2 years before Tim Berners-Lee? Well, Tim Berners-Lee probably was thinking about Inquire then. I'm not sure when the idea first came to him. But this is exactly, so we didn't have a web, but we had two guys trying to build something very similar. And so John Walker got all these great guys, built a building just like Xerox PARC for all the developers to work in, and he made a really clever decision, which is he put Ted Nelson, the architect, in the best possible place for those developers, 1 hour's drive away in a completely different building, so that he couldn't actually bother the developers every day. And John Walker, when all this was announced, said in 1964, that was when Ted Nelson did his first formal presentation of his theory, Xanadu was the dream of one man, that was Ted Nelson. And in 1980, all the guys that he sort of collected over time were all sharing this amazing vision and going to build it. And he said, I'm going to invest in them, and by 1989 it will be a product that we'll be able to sell, and by 1995 it will begin to change the world. Now, I've got, let's see if I can get my, just so that you get a very quick view of what Ted Nelson was talking about. In 2007, so a long time after all this was done, bits of Xanadu have come out as real bits of software over time. This one takes a little while to load. And I may have to kill it if it takes much longer. So you get, every now and then, you can actually take a piece of code. It's nothing like the web. It's not joined up or anything. But, oh, it's running on this. Right. Here we go. This is Xanadu. This was released in 2007. So if I scroll to the top, this is a document. This isn't fake, by the way. This is a real, in the file system sitting behind this, this is an actual kind of HTML-like document. It's about Ted Nelson, big thinker, the origins of human existence. And if I scroll down that, document, you can see that it's got some links, but these are transclusions. They're not actually links. This is taking text. This is biblical reference that starts it off. It's actually taking text from that document and dynamically including it in that document. And as I go down, you can see that there are links of different colours. I would spend more time on this, but we're already over, nearly. And I can zoom to the side, and I can actually see in 3D, and in fact, I can even, look, I can even zoom in and fly all the way through. Anyway, get the idea. And there you go, all the way through to the other document. That would probably suck if it was running in a browser, but you kind of get the idea of where he was coming from. It's a bit, it's a bit more sophisticated than the web, but you get the idea that it was actually quite a technical challenge to try and do that. And so in 88, when John Walker actually funded them, there wasn't really the technology around to do it, so he was kind of on a hide into nothing. Okay, so what was ironic is in 1995, when John Walker said it was going to be changing the world, unfortunately the world was being changed, but it was being changed by Tim Berners-Lee's web. And then this issue of Wired came out with this article in it called The Curse of Xanadu, and it was written by a guy called Gary Wolfe, and Gary Wolfe called it the longest running vaporware project in the history of IT. And let's be fair, he'd started thinking about it in 1960, still not done now. Bit like some of the projects I've worked on. So this was kind of the nail in the coffin really for Xanadu. The team split up and they all went off to go and actually earn some real money. So the kind of question is, well, is that game over for Ted Nelson and all his ideas? He's, what is it, about 80 odd now? And normally you'd sort of write that sort of stuff off, but this guy, Jonathan Van Post, who was voted the geekest geek of all time last year, he is a truly, truly amazing guy. He is the only guy, as far as I know, who's been a professor in practically every subject known to man and taught it at major universities. So super bright guy, probably doesn't code. But he actually said that he didn't believe that it was complete insanity. He actually thinks that they were on the right track, but possibly not technically astute enough in order to be able to deliver it. Although he did add a rider at the end, which is that he wasn't particularly keen on taking on the software development, which I kind of agree with. So, is there any meaning in all of this stuff as far as you know, the online domain and so on? I think there's a couple of things we can sort of take away, which is the software world today is the web. I mean, everything gets built and there's always some web technology. I mentioned priority moments before. The digital channel strategy for the OIPD domain is very HTTP centric. It kind of rings through in all the different things that we're talking about. And that means that going to vendors and buying expensive software is going to happen less and less. That simple fact I gave at the beginning, 5 years for a product versus 10 years for a bought thing. The vendors, except maybe Google, vendors don't really own the web in the same way that they own, you know, kind of your ESB infrastructure or whatever. And I think the more that this kind of software sort of permeates into the enterprise world, the less that vendors are really going to have a leg to stand on. So let me just bring these up really quickly. So if we were to sort of think about some of this stuff internally in O2, so we have control of our own network. We can actually interrogate using REST. We can interrogate customers over HTTP. We can say that our customer data and our product data could be as distributed as we like it to be. Data is distributed all over the web. We don't need to spend millions of pounds on a migration program in order to put data in one place. We could have links that mean something. So, like I say, at the moment, in our REST architecture for the e-commerce stuff, we're always kind of wrangling with what a link actually means and where it goes, because a link is just a dumb thing. It's just a sort of, it's a hypertext jump out to somewhere else. But we could start to add some semantic meaning to our links. And why not have links that work both ways? All that really requires is some kind of concept of a bit of software that sits in the middle that's making sure that those links do actually traverse. So why not go from a customer to a product, get all the products that they've got, or get a product and find all the customers that own it? And be able to go from anywhere to everywhere inside our network of twingularities without breaking those links. And also see the change history. So these are kind of Ted Nelson's things applied to O2. My final word on this comes from this guy, Vint Cerf, who appears in all the research I did when I was reading up stuff for this presentation. Vint Cerf's name keeps coming up over and over again. He's the chief internet strategist at Google. He's one of the guys that's been working on a protocol called Speedy, which is an sort of extension. It's an add-on to HTTP that sits underneath it, which makes HTTP much, much faster. It's a Google kind of proprietary thing at the moment, but they are talking about making it an open standard. And he said about Xanadu that if we can learn one really important thing, it's that, and this, I think, to me, this tells you everything you need to know about architecture. Delivery is everything, obviously. It's what we get paid for, it's what makes us feel good, it's what delivers value to the business. But we can also say, that's kind of our end of the day view, that we come to work in the first place because of the vision. I mean, that's what drives us. The delivery is what kind of ties it all together. And he said, and this is really Google's strategy, is you take what you've got that works, and then you add micro, what do they call them? Micro standards. And so you basically incrementally improve it. So I think what we're going to see is a lot of Ted Nelson's ideas. He won't get Xanadu. Xanadu will never be a reality on the web. Tim Berners-Lee is the web that we've got. But by adding micro standards on top of what we've got, I think we'll incrementally be able to actually make hyperlinks much more meaningful, probably starting internally in networks that we do control, and then as the standards develop externally, we'll be able to actually do much more sophisticated things. And that is the end.
Can everyone hear me?
I've got a microphone that works. You want it?
Okay.